Hello student. Now I'm going to start lecture 4, right? Lecture 1, 2, 3 students already I uploaded. So go and watch. And now I'm going to start lecture 4. So this is lecture 4. Okay. So in this lecture student, what I'll discuss major point. This is pressure distribution. What, my dear? Pressure distribution in a static fluid. As you know, everyone, we are learning what is student? Static fluid only, right? So in today's lecture, I'll discuss this is what, my dear? Pressure distribution in a static fluid, right? So here students, we have discussed that static fluid, the distributions of pressure and uniform in horizontal direction. Students, these things already I discussed in previous lecture, right? So now students, I'm going to start this concept behalf of, I can say, numerical, right? So what's numerical, students? As an example, we can treat find pressure due to liquid on the base of container. Find pressure due to liquid on the base of container. This is point number 1, students. Questions number 2. Find force on the base of container, right? So there are, student, there are 2 questions, right? So now I'm going to solve the questions. How this is, student? So for this condition, first draw diagram. Now students, you can say this is a container, right, student? Okay, this container open all to atmosphere. Students, in this container I'm considering here H is what? Fluid. H is the height. It's not a height of container, it's a liquid filled in a container. Now friends, this is container open to atmosphere. Students, here I'm considering A is area of cross section of container, my dear, right? Okay. So now students, for this things, what is means area, not a cross section, students? You can say this is what, my dear? This is base area. It's a better call to this. Okay. Now students, here we wish to find what? What's initial, student? This is a pressure, right? And second is what? Force. So students, yesterday already I said what is the pressure for a liquid, because I took a separate lecture 3, on the behalf of, I can say, only pressure definition. So students, yesterday I explained pressure is nothing but it's what, my dear? It's what, my dear? This is normal force per unit area. Students, we will go for depth study of this one. Then what already I say in previous lecture, students know there is a normal force. Normal due to liquid acting, normal due to liquid acting on the container. In this direction, as you know everyone, liquid force always acting normal to surfaces. Now students, this is in this directions, another student, this is the side of container, so this is a normal directions, and so this are what you can say cancel each other. So you think about who is maintaining equilibrium of this fluid amount, right? Students, also you can say find pressures due to gravity. These all are questions remain same only. So now friends, just you can make a video of this container. Now you can see what, because this liquid is in contact with container, you know, I can see in NLM there is a kinds of force, right? Contact force, normal force, tension force, friction force, these all are contact force. So normal and friction mandatory conditions, there is a two body must do in physical contact. Students, you can see this is the liquid in what contact with the what, you can say container. Here students, you can write due to this normal acting, this is students are making FVD of fluid. Keep in your mind, this is what my dear FVD of fluids. So let us suppose this is the container, liquid touch with the container due to this normal acting in upward direction. So my dear, you can see this is normal. Why system in vertically equilibrium? Because they are what, equilibrium, and they are what you can say equal and opposite forces. So you can say for vertical equilibrium, my dear, for vertical equilibrium, what students, you can say now normal is equals to what, my dear? Normal is equals to mg. Normal is equals to what? Mg, my dear. Already I said why it's in equilibrium in horizontal, why in vertical. Now I'm going to find our answer. So what's BB is to find a student? Pressure. So you can write pressure is equals to what? Normal force. It's normal itself. So normal, and what's the area of the container? That is, you can say A only. So now students, normal, as you know, already we found normal is equals to what you can write. This is mg upon area. Students, I said there is a relation. There is a relation between what? Density and volume. So you can write density is equals to mass per unit volume, my dear. Students, here you can say mass is equals to density into volume. Mass is equals to what, student? Density into volume, right? So students, I'll use this tool over here. So students, here I can write pressure is equals to rho V G upon what, my dear? Area, right? Students, rho is what you can say remains same only, rho only, because it's a fluid. You can take density of fluid is what? Rho. Okay, so students, this is rho remains same. What is the volume, students? I hope all of you remember. I'm expecting this basic definition from your side. Volume is nothing but what, my dear? Area into length. What you can say, my dear? Volume is equals to area into length. So here you can write what's the length. This is liquid filled in the container. So L is equals to, you can take H, right, my dear? So you can write V is equals to A into H. So finally, students, you got volume. So you can write over here pressure is equals to A H into G upon what, my dear? A. Now you can say this cancel each other. So students, finally you got pressures due to liquid on the base of container. How much? Rho GH. Students, you can take snapshot, right? I'm giving you 5 seconds. Now students, after this student, I'll just move on next paper, right? You can take snapshot. Okay, I hope you have taken. So now students, I'm going to turn the page. So what we got finally, this is what, my dear, pressure due to liquid on the base of container. How much, student? This is rho gh. This is what, student, we got pressures due to liquid on the base of container, rho gh. Student, this is only liquid pressure. As I said, students, I wanted to show again, this container what, open to atmosphere, right? So what you can take, gravity force is, gravity pressure is also there, right? So this is the pressures due to liquid, students. Second part, students, also we have to find what, force on the base of container due to this liquid. Students, here I am going to use force is equals to pressure into what, area, right? Simply, students, you know, I hope I'm expecting this definition basis from your side. Pressure is what, force per unit area. So students, this is again, you can see this is not force due to what, liquid on the base of container. So what is, students, this is, you can write P is what, pressures due to liquid. So you can write rho gh into A. So finally we got, as I asked student, there are two questions. Find pressures due to liquid on the base of container, finished. Find force on the base of container, finished. So there, let us suppose if they wanted, they have a freedom, they can ask what is the total pressure. Students, you can say what is the pressure total, or you can say pressures net. So this is what, students, you can write pressures due to atmospheric pressure plus pressures due to liquid. So pressures due to liquid, students. So net pressure, you can write this is P naught plus rho gh, right? Students, here you can connect this formula from mathematics. How? Just little rearrange. Students, little rearrange. You can say pressure net is equals to rho gh plus P naught. You can do left right. Now, students, this expression you can connect from mathematics, that is by is equals to mx plus c. You know, these two are, students, you know, look like similar. So what is by? It's the pressure. So here, students, you can say slope is what, positive, intercept, students, also positive, both are positive. So here I'm telling you, students, you have to draw graph, pressure versus, students, here you have to draw graph what, pressure versus height, right? In fact, there is not much, just little go to this. Yes, beta, this is what, pressure versus height graph. So what you can say, initially we have something, so definitely graph will start it from here only. So this is, students, and what's the here, what's the value over here? This is the P naught. So just keep in your mind this which I explained you, literally highly important. I know entire class will discuss only this. So this is, now onwards, keep in your mind what is the pressures due to liquid on the base of container. This is rho gh, right? Students, after this, what I can say, we can now see the pressure is. Now, students, just there is little changes. Students, you can say not little changes, it's just understanding better. Students, you can say pressure is what, directly proportional to height. So students, I can conclude one point, pressure is directly proportional to what, G, you know, G always constant, G always constant. So pressure is directly proportional to density and what, the depth of liquid, that's all. So what is the conclusion, students? For a static liquid, the pressure is what, independent of direction also, independent of what, direction also. So students, conclusion I wanted to write as a note to students. You can take first snapshot, right? Then I'll turn the page. Okay, fine. I hope you take it. And now students, I can say there is few points. Students, note, or you can say it's a conclusion point, or you can say, my dear, it's a conclusion point, right? So what is the point, students? We can now see, students, we can now see as per the process, pressures liquid, rho, gh. So pressure is directly proportional to density and height, student, right? So now, student, what we can say, pressure depends on depth and not on the cross section. Students, you can say the pressure depends on the depth and not on the cross section. Not on the what, students? Cross section means area, you can select, right? So pressure depends on what? Only what's the height, liquid height filled in the container. That's all. Now students, I can say there is a point, students, which I wanted to discuss, or we'll go through the next numerical, students. Now find pressure at point A, B and C. Figure shown, my dear. Okay. Fine. So what's this, students? This is the diagram you can consider. Yes, beta ji. Now students, I'm calling. This is point A, student. This is point B. This is point C. Students, height of the liquid, which is remains same for all the points, which is H only. In the container, this is A, B, C. I wrote again for better visibility, A, B and C. Student, this is point A, this is point B, this is point C. Student, at C there is no at all. Now let's talk about, I can say, solution, students. So what, students, I can say over here for this condition. Students, for this condition, what you can see is pressure at B, no doubt, it's open to atmosphere, rho gh. But now, students, you can say pressure at V, rho gh. Now, students, we have discussed about what's the pressure at point A and C. That is a major, I can say, down. Now, students, as I said, in yesterday class, just discussion about the pressure, I said, students, if any floating body, not any, you can say there was a floating body, which is, I can say, floating on what? Water. So there is contact. So due to this, students, what you can take, there is what? Normal. This contact. Now, students, again you can take, there is another one more normal at this point. I hope you are getting my point. Now, students, I can say for this condition, so students, for explanation here, I wanted to draw one more diagram so that you can easily differentiate. Diagram, which diagram for explanation and which is for like say questions. This is with a question diagram. So students, this is point A. As I said, this is what, students? Normal. Now students, height liquid remains same, so we can say this is also normal. Now it is a I'm considering over here, you can take anything. Let us suppose I'm considering this angle is what? Theta from horizontal. This angle is, students, again I'm considering over this is what? Theta. So now we can say what? Normal, you can take component, students, normal n cos theta, and what you can say n sin theta. Okay, again students, same thing, you can take n cos theta, this is what? N sin theta. Students, again I'm telling, don't we go there, n cos theta, n sin theta, n cos theta, n sin theta. You can say n cos theta cancelling each other. Who is balancing equilibrium of this much liquid? That is what? N sin theta. Who is balancing this much liquid at this direction? N sin theta. So now students, you can say forces. So due to this, what finally you can write, my dear? Pressure at A is equals to pressure at V is equals to pressure at C. Every point. Why? Because height remains same, and normal is what? Balancing this much area of a liquid. I hope you got the solution of these questions. You have to take snapshot, then I'll move on next slide, or I want you to turn the page. Okay, I hope you've taken. Now students, just move on the next one. Students, so what is this? I can say next questions. Liquid is, or you can say, students, as example you can treat, that is more better for you. Students, liquid is filled in an irregular shaped container. Okay, then students, as an example you can treat, it's better for you, you can easily understand. If there is shape is not regular, then students, they wanted to ask what's the pressure. That is one more thing, Buddha, students, and core point. Let us suppose I'm considering this is container A, right, in which height, student, this is remains h only. I'm calling this is at point 1. Now students, you can take, as I said, irregular shape. So now student, this is the height of liquid remains same, h only. Height of liquid, what my dear? H only. Now we can say this is a regular shape. Okay, but one point is, this is remains common. That is what, my dear? Height of liquid. Height of liquid, students, filled in all container is remains same. Then you have to find pressure at A, B and C. Pressure at A, B and C. Now students, you can easily say, as I said students previously, that is what? Pressure depends on the depth, not on the cross section. Student, I said in previous, I can say example, pressure depends only on height or depth of the liquid into the container, independent on what? Area of cross section. So what's answer, my dear? You can write in answer, that is what? Remains same. That is, students, you can say remains same. This is what? Pressure at A is equals to pressure at V is equals to pressure at C. So this is answer for this question. How easy here? Students, you will get this kind of easy explanation of physics at physics point only. You will not get another place, because here I'm discussing each and every points, so that you can easily, you are not in front of me, so that I'm trying to convey message honestly, so that you can understand the things. Now friends, have a look of the next numerical, right? Students, let us suppose here, find pressure due to liquid on the base of container. Figure shown, my dear. On the base of container, figure shown. Okay, liquid only ask this, right? So what's the question, student? You can take like that. Students, here I'm going to fill. I wanted to fill, there are two liquids, different. So you can see this is what? Density rho 1. This is what? Density rho 2. It's very obvious now. What you can say, density rho 2 is more than that. Okay, so this is rho 1 right here. Another one, you can say this is what? Rho 2. You can write, students, this is H1, and this is what, students? You can say S2. What is the pressure over here? You can just go through for solution, students. Easiest way. You can tell very easily. Student, don't be hesitate, right? What is the pressure over here? Due to this liquid, you can say rho 1 G remains constant, rho 1 G1 H1. So let us suppose, you can say pressure 1. I'm calling this compartment, students, I'm calling like A, this compartment at B. So you can see beta pressure at A, student, this is what? Liquid, rho 1 G H1. Now students, what you can say in step 1, pressure at B. Pressure at B, what you can say? At V, we'll realize both of this. So what, students? You can say rho 1 G H1 plus rho 2 G H2. Right. So this is, I guess you wanted to find net. So students, pressures on the base of container. Step 2 is supposed to write, this is, because here I'm not considering what's I can say, this is a liquid pressure due to liquid on base of container, my dear. What you can say, rho 1 H1 plus rho 2 H2 into G, right, my dear? Okay, let us suppose they can ask, this is, I'm just adding one more questions, right, my dear? Okay, so this is what I can say, step 3. What is the net pressure? So just nothing is going, just you can add atmospheric pressure, P naught plus what, students? Rho 1 H1 plus rho 2 S2 into G. So students, these are the things which supposed to, I can see this class. Remaining things, students, stay tuned. I'll discuss in next class. Take snapshot,